So here's a classic, the ladder sliding down the wall. If you watched one of those Essence of Calculus videos from last week about the chain rule, he also talked a little bit about a related rates problem that was essentially this related rates problem, the ladder sliding down the wall. I think the numbers are different, the application might have been slightly different, but the idea is precisely you've got a ladder and it slides down, okay? So if you see the way it's written here, I've got a 13-foot ladder leaning against the house. The base starts to slip away. By the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. How fast is the top of the ladder sliding down the wall then? Okay, this is an interesting problem. You have to be careful with setting this up so that you can figure out what they want to do. So, what we want to do. So, if we draw our triangle, right, you've got this ladder. It's 13 feet. The size of the ladder isn't changing. So I'm going to label that 13 because it didn't look like a 13, it looked like a B. Now it looks like a 13. So, all right, so that hypotenuse, remember it started out here and then it's going all the way down until, of course, it's flat, right? So the hypotenuse is not changing, though. The ladder doesn't change size, but both of the other sides of the triangle are changing because as it goes down, this height gets smaller and this length gets longer. So I'm just going to call them X and Y just because that's like our standard horizontal and vertical. Then the question, and this is a key thing I think I mentioned in the previous video, but it's even more important here. The question gives me some other information. The base is 12 feet from by the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second, blah, blah, blah. So, but we don't want to put in the 12, right? The 12, it's only 12 feet at a particular instant. Okay, so we want to keep that for the very end because they're asking for how fast the top of the ladder is moving, again, at that instant where X is 12, okay? But we have to start out with a relationship that holds for the whole time of the problem, from the point where it starts slipping away to the point where it's flat, okay? So we need a relationship first between the variables X and Y that really doesn't have anything to do with time yet. And then we can talk about taking the derivative and looking at the rates where these things change. This part is not hard, right? The relationship between X and Y is obvious. It's the Pythagorean theorem, right? So we just write that down. Oh, you know, I forgot to write down what the variables were. What's 13 squared? 169? Okay, so I do like to write down what the variables are. So X is the base distance and Y is the height, right, of the height, a vertical height. Let's pull a vertical height. Height on wall, how about that? Dx dt is going to be the change in X. So that's the rate at which the base is moving, right? And what about dy dt? That's going to be the rate at which the height is changing, right? So the rate at which the top is changing. So rate that the ladder is sliding down. Rate the top is sliding. Okay, so the change in the vertical direction versus the change in the horizontal direction. So the question actually, if you ask, what is the question asking? The question is asking for this, dy dt. How fast is the top of the ladder sliding down the wall then? So this is what we need to solve for. in the end. Okay? What they did give you is they gave you this information about how the two are related, and then also they gave you this information about the rate that the base is moving and the type at the point that they're interested in. So we'll get to that later. So because I need to know that I need to solve for this dy dt, I'm going to solve for it, right? I'm going to take the derivative of both sides with respect to t. So d dt of x squared plus y squared equals d dt of 169. Well, 169 isn't changing. So this is 0. Now both of these, remember, I'm taking the derivative with respect to t. So although it's like the implicit differentiation, my variable isn't x, it's t. For both of these, I'm going to have 2x dx dt plus 2y dy dt. Okay, so now I said I wanted to solve for dy dt. I'm going to solve for it. Dy dt then is going to be I'm going to put that one on the other side. The 2's are going to cancel. I'm going to get minus x over y dx dt. Great. So now I'm almost done. I like it, right? It's almost done. So now I can, now that I've solved for my dy dt, I can start putting in my numbers that were in the problem. Okay, so x, well, the time that they're interested in, the time that they're asking about, is the time when the base is 12, so x is 12. And then I know this is dx dt, the rate at the base is moving, so that's this is dx dt. So I can put in 5 feet per second there. But I don't know what y is immediately, right? Because they didn't tell me that. So at this point, I have to go back to my original thing and say, now I can think about what's going to happen when y is 12. No, sorry. When x is 12, like, wait, when x is 12, what is y? Well, I can just solve it with this right triangle, right? And you don't even need to really solve it, right? Because it's a 5, 12, 13. 13, 12, 5. Y is 5 at that point as well. So it's only, I don't know why they made it 5 here, just so that it worked out pretty, I guess. I don't know. But those two are sort of separate because it could be going at a whatever rate they told you. Okay? So that cancels that, and my answer then is minus 12, again, feet per second. Okay? Why is it minus? Because the height is going down, right? This height is this length is getting bigger. As the ladder goes from here to here, this length is getting bigger, so it's positive. It's moving positively. This height is getting smaller, so its rate of change is negative. Okay, so it's okay to have a negative answer as long as it makes sense physically in the problem. And sometimes we'll see in the later problems that we have to figure that out, like, is it positive, is it negative? Here you can see that this guy is going to be, this 5 is going to be positive because that base is getting bigger. X is getting bigger. So dx dt has to be positive.